So let's use the sea. Cletus can see 15,000 kilometers or more to the Sun, but he can't see all the sea stretching out as far as the flat Earth flying spotlight either. Stood a couple of meters above the sea, the horizon is a mere 5 kilometers away, and on a really clear day it's as crisp as you like, clearly showing that you can only see the surface of the sea to a short distance, and that's it. Well, why can't you see the sea beyond that when conditions are so clear? Think back to our earlier discussion. You should be able to. So here's what flat earthers think reality must look like. Cletus is looking out over the sea at the equator on an equinox. His line of sight is 2 meters above water. The Sun is 15,000 kilometers away and appears down here because fuck geometry and perspective. Cletus can see the Sun setting. However, when he looks at the sea, he can only see as far as 5 kilometers, because fuck geometry and perspective. Why can't he see thousands of kilometers of sea or land beyond that? Why can't he see them even though there's clearly nothing in the way? Because reasons, and because fuck geometry and perspective. The only possible flat-earth explanations for this involve cocking up geometry as we saw earlier, or invoking strange new properties of light that nobody's ever heard of, nobody has measured, and nobody has observed. Maybe light from the surface of the sea or land more than 5 kilometers away just gives up. It just stops trying to reach your eyes. You can't see any sea beyond that, because reasons. The sky, however, isn't subject to this restriction, and so light from the sky and from the Sun thousands of times further away is clearly visible. The light from other objects more than 5 kilometers away also aren't subject to any magical distance restriction either. Distant ships, structures, buildings, mountains are all visible and appear obscured by the horizon, because fuck geometry, fuck perspective, and fuck consistency in the flat earth world. In reality, the distance to the horizon depends on the observer's altitude, which also knackers the lazy light idea, because as any fool knows, when you're higher you can see further. So if we put Cletus on a 100-meter high hill, he'll now find that photons that couldn't be asked travelling more than 5 kilometers before now can be asked to travel more than that just because Cletus changed his height. In fact, they'll travel 7 times further, and Cletus' horizon will now be 35 kilometers away. He'll also be able to see more of those partially obscured ships, structures, buildings and mountains, and if he's really quick getting up the hill, he can even watch the sun set again. Coincidentally, the distance to the horizon on a clear day is exactly what you'd expect at a given height above the surface of a spheroid around 12,700 kilometers across, which is the size of the Earth.